Hello everyone, welcome to Arcan Chemistry YouTube channel. In this video, I'm going to discuss NEET Previous Year Questions from classification of elements and periodicity in property. Let's start. First question. Which of the following statements are true? This is NEET 2025 question. Which of the following statements are true? Okay, what is first statement? Unlike gallium, that is a very high melting point. What is written here? It has a very high melting point. No, gallium has a very low melting point. Okay. Cesium has a very low melting point. Cesium has a very low melting point. This is correct, but gallium has a very low melting point. Okay, we know in periodic table, gallium, cesium, francium, mercury. These are the metals in the periodic table which has a very low melting point. Which is very low melting point. Even mercury is a liquid at room temperature. Mercury is a liquid at room temperature. Though these metals are not liquid at room temperature, but if we'll increase the temperature up to 30 to 40 degrees Celsius, 30 to 40 degrees Celsius, these metals will become liquid. So they have very low melting point. They have very low melting point. But in this question, it is written as gallium has a very high melting point. That's why this statement is wrong. That means first statement is wrong. Okay. Let's come to second statement. On Pauling scale, electronegativity value of nitrogen and chlorine are not same. What is it? Not same. What is it? Not same. You have to focus on not. What we know in Pauling scale, nitrogen electronegativity value is 3.0 and chlorine electronegativity value also 3.0. That means these are same electronegativity. Same electronegativity. Same electronegativity according to Pauling scale. According to Pauling scale, they have same electronegativity. But it is written in second statement not same. That means this statement also wrong. Okay, next come to statement number C. Argon, K plus, Cl minus, Ca2 plus, and S2 minus are all isoelectronic species. Let's see. Argon isoelectronic. What do you mean by isoelectronics? I said it before also. Iso means same. Iso means same. Electron means electron. Electrons. Electrons. That means the species having same number of electrons. The species having same number of electrons are known as isoelectronic. Let's see is this species has same number of electron or not. Argon, we know atomic number of argon is 18. So it has 18 electron. Yes, correct. It has 18 electron. Potassium atomic number 19, it is 19 electron. But plus 1 means loss of 1 electron. That means it also has 19 minus 1. That means 18 electron. Chlorine atomic number 17. Minus means gain of 1 electron. 17 plus 1. That means it has also 18 electron. Similarly, calcium atomic number 20. Loss of 2 electron. 20 minus 2. That means 18 electron. Sulfur atomic number 16. It has 16 electron. 2 minus means gain of 2 electron. 16 plus 2. That means 18 electron. That means all these species has 18 electron. All these species has 18 electron. That means these all are isoelectronic. That means this statement is correct. Okay. Next statement number D. The correct order of ionization enthalpy of sodium, magnesium, aluminum, and silicon. This is the order given. This is correct or wrong? Let's check. Okay. We know that sodium, magnesium, aluminum, and silicon all are one period element only. Sodium, magnesium, aluminum, silicon. We know from left to right ionization potential increases. That means this should be the order. This should be the order. But we know magnesium has a stable electronic configuration. What is its configuration? Neon 3s2. 3s2. S has one orbital. In one orbital, 2 electrons are there. That means exactly fulfilled configuration. Element having exactly half filled configuration or fulfilled configurations are highly stable. Exactly fulfilled configuration. It is exactly fulfilled configuration. Exactly fulfilled configuration. Exactly fulfilled configuration means highly stable. Highly stable. As it is stable configuration, so it will not lose electron easily. So its IP value will increase. How much it will increase? Its IP will increase next to its corresponding member. That means what should be the order? Magnesium will go there, aluminum will come here. That means what should be the order? Order will become sodium less than aluminum less than magnesium less than silicon. This is the increasing order of IP, but in options in the statement is given decreasing order. That means answer should be silicon greater than magnesium greater than aluminum greater than sodium. Okay, the change in this IP of magnesium and aluminum due to stable configuration of magnesium. So what should be the answer? Answer should be silicon greater than magnesium greater than aluminum. But here that means aluminum should go here, magnesium should come here. That means whatever the statement given, this is wrong. Okay. As magnesium is stable electronic configuration, its IP will be more than that of aluminum. That means this statement is wrong. Next, the atomic radius of cesium is greater than that of lithium and rubidium. Yes, this is correct only. Let's see. We know lithium, rubidium, cesium, these all are alkali metals. Lithium, sodium, potassium, rubidium, cesium. We know left to right atomic radius increases. Left to right atomic radius increases. Left to right atomic radius increases. That means cesium has higher atomic radius than rubidium and lithium. That means the statement is correct. Cesium has a greater radius, greater than that of lithium and rubidium. That means this is also correct. That means what should be our answer? C and E. C and E. C and E means second option is our correct answer. Okay, next we go to question number 2. Which among the following electronic configuration belongs to main group element? Main group element. Okay, which of the following configuration belongs to main group? We know in periodic table, in periodic table, we know in periodic table, if this is the periodic table, if this is the periodic table, okay, this is group number 1 to here group number 3 to 12, here group number 13 to 17, here group number 18. Group number 1, 2 and 13 to 18. These are known as main group elements. These are known as main group elements. Main group element. That means S block, S block and P block element. S block and P block elements. S block and P block elements are combinedly known as main group element. Are combinedly known as main group element. Main group element. S block and P block elements are combinedly known as main group element. That means we have to find from this given A, B, C, D, E, which are S block and P block elements. Let's see first. Neon 3s1. Neon 3s1 means this is sodium. Sodium is S block element. You will find sodium here. Yes. Next, argon 3d3. Argon 3d3 4s2. 4s2 3d3 means this is a D block element. You will find here scandium, titanium, vanadium. That means this is vanadium configuration. It's vanadium configuration. So this is a D block element. This is not a main group. This is a S block element. This is a main group element. Okay, next, C. Krypton 4d10 5s2 5p5 ns2 np5. What is this configuration? ns2 np5. We know halogen configuration. Halogen configuration is ns2 np5. Fluorine configuration is 2s2 2p5 2s2 2p5. Next to fluorine, chlorine, bromine, iodine. Okay, then chlorine configuration is 3s2 3p5. Bromine configuration 4s2 4p5 4p5 4p5. Iodine configuration will be 5s2 5p5. That means this is a p block element. This is a p block element. This is C is nothing but iodine. This is also main group. P block element means this is main group. Main group means S block and P block you have to mark. This is a P block element. Next, argon 3d10 4s1. 3d10 4s1 means this is copper configuration. Copper you will find here. Copper is a transition element. So this is not a main group element. Okay. Next, Radon 5F0 62 7s2. We know radon atomic number 86. Then 6s2, that means 2, 7s 62, 7s2, that means 2 to 4, that means atomic number 90. Atomic number 90 is nothing but thorium. Thorium is a what inner transition element. This is a inner transition element. Inner transition element. Transition element. This is a inner transition element. That means this is not a main group element. This is not a main group. Main group means only S and P block. That means what is our answer? A and C. A and C means option number 2. A and C only. Option number 2 is the correct one. Next come to question number 3. Arrange the following elements in increasing order of their electronegativity value. Increase order of their electronegative value. Okay. We know these up to this these are one period element. Okay. Carbon, nitrogen, oxygen, fluorine, carbon family member, silicon. Okay. We know left to right electronegativity value increases. Electronegativity increases. Fluorine has highest electronegativity, that is 4.0. Oxygen electronegativity 3.5, decrease by 0.5. Here also decrease by 0.5. Here also decrease by 0.5. So nitrogen electronegativity value will be 3.0. Carbon will be 2.5. When the top to bottom decreases, so silicon electronegativity value will be less than that of carbon. Its electronegativity value is 2.1. So what is the order? Fluorine has highest electronegativity. Fluorine has highest, then what will the order? Silicon will come at last, less than carbon, less than nitrogen, less than oxygen, less than fluorine. And what is the answer? Fluorine, oxygen, nitrogen, carbon, silicon. That means option 3 is the correct one. Third question, option 3 is the correct one. Next come to question number 4. Arrange the following elements in increasing order of their ionization enthalpy. Increasing order of their ionization enthalpy. Lithium, beryllium, boron, carbon and nitrogen. Lithium, beryllium, boron, carbon and nitrogen. These all are one period element only. Lithium, beryllium, boron, carbon, nitrogen. We know left to right, left to right, we know left to right ionization potential or ionization enthalpy increases. Left to right ionization enthalpy increases. Then what should be the order? Order should be like this. Order should be lithium less than beryllium, less than boron, less than carbon, less than nitrogen. But what is the twist here? Beryllium, we know beryllium atom number 4, it is stable electronic configuration. Its configuration is 1s2, 2s2, exactly fulfilled configuration. 2s 2 electron, that means exactly fulfilled configuration. Exactly half filled or exactly fulfilled configuration are highly stable. Highly stable means their IP will be comparatively more to the next member. That means beryllium will come here, boron will go there. And what will the correct order? Lithium less than boron less than beryllium less than carbon less than nitrogen. Then what is the correct answer? Lithium, boron, lithium, boron, and lithium, boron. Option number 4. Lithium, boron, beryllium, carbon, nitrogen. Option number 4 is the correct one. Option number 4 is the correct. Okay. Next come to question number 5. The correct decreasing order of atomic radius of lithium, beryllium, boron, and carbon. Lithium, beryllium, boron, and carbon all are one period element only. Lithium, beryllium, boron, carbon. We know left to right. We know left to right atomic radius decreases. Atomic radius, left to right atomic radius decreases as effective nuclear charge. That means Z effective increases. Left to right, electrons are added in same cell. Electrons are added in same cell, but proton number increases. That's why effective nuclear charge increases. As effective nuclear charge increases, attraction increases. Effective nuclear charge increases means attraction also increases. If the attraction increases towards the outer electron, radius radius decreases. That means left to right atomic radius decreases. Atomic radius decreases means lithium should have higher radius than beryllium, then boron. And what is the correct answer? Lithium, beryllium, boron, carbon. Second option is the correct one. Lithium, beryllium, boron, carbon. Question number 5, second option is the correct one. Next, question number 6. The element expected to form largest ion to achieve the nearest noble gas configuration. Okay, sodium atomic number 11. Its nearest noble gas nearest noble gas is neon, whose atomic number is 10. How it will achieve nearest noble gas configuration? If it will lose one electron, that means sodium will lose one electron, so form Na positive, sodium plus N. This is configuration is 2, 8, 8, nothing but neon configuration. Okay. How oxygen will achieve its noble gas configuration, nearest noble gas configuration? Sodium will achieve by loss of one electron, that means Na plus, sodium Na plus. Oxygen will gain 2 electron, that means O2 minus. Fluorine will gain 1 electron, fluorine atomic number 9. Fluorine atomic number 9. So it will gain 1 electron to achieve noble gas configuration, neon configuration, that means F minus. Oxygen atomic number 8, sodium atomic number 11. Next one, nitrogen. Nitrogen atomic number 7. If it will gain 3 electron, then it will achieve noble gas configuration N3 minus, that is neon configuration. Then you have to find what you have to find expected to largest ion, then whose size will be largest? Na plus, O2 minus, F minus, and N3 minus. First, understand the question. The element expected to form largest ion to achieve the nearest noble gas configuration, and that means sodium will achieve noble gas configuration, oxygen, fluorine, neon, sorry, nitrogen. All of them will achieve noble gas configuration. After achieving their noble gas configuration, whose size will be bigger? You know, this is a cation. These all are anions. We know anion size is greater than that of cation, but these all are isoelectronic. These all are isoelectronic. That means same number of electron. Isoelectronic. For isoelectronic species, radius for isoelectronic species, radius inversely proportional to atomic number. Inversely proportional to atomic number. We know sodium atomic number 11, oxygen 8, fluorine 9, nitrogen 7. So what should be the order? Inversely proportional to atomic radius means sodium radius should be least. Sodium least, then 9 fluorine, then 8 oxygen, then nitrogen. Then which this is the order of their ionic radius: Na plus, F minus, O2 minus, and N3 minus. Then according to question, which is the largest ion? Largest ion means which of the largest? Na3 minus is the answer. And sodium. That means sodium is the answer. Sodium is the answer. Fourth option is the correct. Then question number 7. Given below are two statements. One is labeled as assertion A and region R. Okay. A. Ionization enthalpy increases along each series of the transition element from left to right. Yes, from left to right, IP increases. Ionization energy increases. This is correct statement. Okay. That means A is correct. Assertion is correct. Region. What is the region? There is a corresponding increase in the nuclear charge. Yes. Which accompanies the filling of electrons in the inner d orbital. This is also correct. Region is also correct. Assertion is correct. Region is also correct. Now from left to right, ionization enthalpy increases because increase in the nuclear charge. Effective nuclear charge. Here I said just now. Here I said where question number 1, I think. No, question number here. Okay, from left to right, effective nuclear charge increases. As effective nuclear charge increases, their IP value also increases. That means A is correct, R is also correct explanation of A. What is the answer then? Both A and R are correct. R is the correct explanation of A. So first option is the correct one. First option is the correct one. Next question number 8. The correct sequence given below. First is in neutral, then acidic, then basic, then amphoteric oxides. These are the 4 options given. Out of that, we have to find the correct sequence. Neutral oxide. Neutral oxide, only 4 oxides are neutral. What are these? CO, NO, N2, and H2. Okay. Let's see the options. First, NO is there, NO is there, NO is there, ZNO. ZNO is amphoteric. So this is not our answer. Our answer may be 1, 2, or 3. Next, acidic. We know non-metal oxides are acidic in nature. Here carbon dioxide. That means option 1 or 2 may be our answer. Option 3 here given what? ZnO. Zn is amphoteric. ZnO is amphoteric. ZnO is amphoteric. So this is not our answer. Next, basic. Metal oxides are basic in nature. Calcium oxide is basic in nature. So option 2 is the correct answer. Just now I said ZnO is amphoteric. But NO is neutral. NO is neutral. NO is neutral. Acidic. Carbon dioxide is acidic. Acidic. ZnO is amphoteric. Calcium oxide is metal oxides. This is basic. ZnO is amphoteric. Amphoteric. What are the some metal oxides are amphoteric in nature? What are these metals? And these are beryllium. Beryllium oxide is amphoteric. Aluminum oxide is also amphoteric. Al2O3. ZnO, this is also amphoteric. Except that PPU also. PPU amphoteric. And one more, that is SNO. These are the some metal oxide which are amphoteric in nature. Which are amphoteric. Amphoteric in nature. Amphoteric means sometimes they behaves like acidic, and that means they show acidic property as well as basic property. These are the neutral oxide. These are the neutral oxide. These are the neutral oxide. These are amphoteric oxides, and metal oxides are basic. Non-metal oxides are acidic in nature. Okay, that means what is our answer? Option 2 is our answer. First one is neutral NO. Second one is acidic carbon dioxide. Third one basic metal oxide, calcium oxide, ZnO is amphoteric. Yes, option 2 is the correct answer. It's option 2 is the correct answer. Next, come to question number 9. Which one of the following represents all isoelectronic species? Just now I said isoelectronic means what? Same number of electrons. Same number of electrons. Which of the following represents all isoelectronics here? Sodium atom number 11 plus 1 means loss of 1 electron, that means 10 electron. Okay, magnesium atom number 12, loss of 2 electron, that means 10 electron. Oxygen atom number 8, gain of 1 electron, minus 1 means what? Gain of 1 electron, that means 9. Here 10, 10, here 9 electron, that means this is not isoelectronics. Okay, next option number 2, calcium atom number 20, loss of 2 electron, that means 20 minus 2, that means 18 electron. Okay, similarly argon 18 electron. Okay, potassium atom number 19, plus 1 means loss of 1 electron. Loss of 1 electron means 19 minus 1 is equal to 18 electron. Okay, chlorine atom number 17, minus 1 means gain of 1 electron, that means 8 electron. All of these has 18 electron, that means these are isoelectronic. These are isoelectronic means same number of electron. So option 2 is our correct answer. It comes to question number 10. Which of the following is correctly matched? Which of the following is correctly matched? Okay, acetic oxide Mn2O7, SO2, TaO3. Okay, we know manganese forms. Manganese has various oxidation states like 80 forms MnO, MnO2, Mn2, Mn2O7, Mn2O7, Mn2O7. As when number of oxygen increases, number of oxygen increases means acidic nature also increases. Acidic character increases. Acidic character of oxides increases. Number of oxygen increases means acidic character increases. That means MnO2 is a acidic oxide because it has 7 oxygens. 7 oxygen, manganese oxidation state here plus 7. Plus 7. Here oxidation state is plus 7. Here manganese oxidation state plus 4. Here manganese oxidation state plus 2. When oxidation state also increases, oxidation state increases means oxide's nature will become acidic. Metal oxide becomes acidic. Metal oxide becomes more acidic. Becomes more acidic. That means Mn2O7 is acidic. Yes, correct answer. SO2 is also acidic. Non-metal oxide. TiO3 is also acidic. That is first option is the correct one. Amphoteric is no. Beryllium oxide is amphoteric, but gallium is a metal oxide. Gallium Ga2O3 metal oxides are basic in nature. Here basic oxide SnO2 is acidic. Sorry, SnO2 is amphoteric. This is basic. This is amphoteric. Neutral oxide CO is neutral, N2 is neutral, but NO2 is acidic. So which is correctly matched? Correctly matched. First option is the correct one. Next question number 11. The IPC name of the element 119. 119. 119. 119 means what will be its name for 1 on 9 means N. N M. And what is the correct answer? On N M. On this is C. On unium written. This is not correct. On NEM. Here see on nil. On means 1, nil means 0. NEM means 9. This is 109. 109. On octium. That means on octium. Octium means 8. 118. On NEM. This is the correct answer. On means 1. On NEM means 9. 119. Option number 3 is the correct one. Option number 4. On union. That means 111. So what is the correct answer? Option number 3. 11. Option number 3 is the correct answer. Next comes to question number 12. The correct order of fast ionization enthalpy for the given 4 elements: carbon, fluorine, nitrogen, oxygen. Okay, carbon, nitrogen, oxygen, fluorine. These all are one period element only. Left to right, IP, there are ionization potential. IP increases. So answer should be like this. Answer should be like this. But we know nitrogen is stable configuration. Nitrogen is stable configuration. Stable configuration. What is configuration of nitrogen? 2s2 2p3. 1s to 2s to 2p3. This is the outer electronic configuration. 2s to 2p3. P has 3 orbitals. 3 orbital, 3 electron. That means exactly half filled. Exactly half filled. Exactly half filled. We know exactly half filled or exactly full filled configurations are highly stable. That means nitrogen is stable configuration. As it is stable configuration, its IP will be more corresponding to its next element. So nitrogen will come here, oxygen will come here. Then what should be the correct answer? A carbon less than oxygen, less than nitrogen, less than fluorine. Then what is the answer you find? Fluorine is highest. Yes, fluorine is highest. Fluorine next, nitrogen. So fourth option is the correct one. 12th, fourth option is the correct one. Next question number 13. The fast ionization enthalpy of element X. X is there. One element X is there. It's IE1. IE1 is given. Fast ionization enthalpy means IE1. 419 kilojoule per mole. Okay. Let's see IE2. Okay, let's see. X, two elements are there. First element ionization enthalpy of X and Y. Y is also there. Its ionization potential value is given. What is its ionization IP given? 590. Y fast IP is given. Its fast IP is given 590 kilojoules per mole. Okay. Respectively, and second ionization enthalpy of X and Y. X and Y second ionization enthalpy. X second ionization enthalpy is given 3069 kilojoules per mole. I2 of Y is given 1145 kilojoules per mole. Okay. Then what is the question? Then correct statement. What is the correct statement? Okay. X and Y are alkaline earth metal. X is alkali. Y is alkaline earth metal. X is alkaline earth metal. Y is alkali metals. Both X and Y are alkali metal. Let's see. That means X, Y either they may be alkali metals or alkaline earth metal. We know for alkali metals, their IP value is less. Alkali metal ionization enthalpy value, IP value is less. Value is less. If you compare the IP1 of X, X is 400, X is 400, X is 490, Y is 590. That means which is a low IP? X is a low IP, low IP. Okay. If alkali metal, that means their outer electronic configuration will be NS1. After losing this one electron, they will achieve noble gas configuration. Noble gas configuration. Noble gas configuration means highly stable, highly stable, Highly stable means their IP will be extremely high. IP will be extremely high. Extremely high. Okay, let's see. IE2, that means already one electron lost. After losing one electron, this IE1 value is 419, but IE2 value is 3069. That means here a high jump, high jump, high jump in IP. Ionization potential, because after losing one electron, it is achieving noble gas configuration. If noble gas configuration means it's highly stable. Highly stable means its IP value will be more. That's why X is a alkali metals. X is a alkali metal. X is alkali metal. Okay. Next come to Y. Its I1 is given 590. I2 is given 1149. We know I IP3 or IE ionization enthalpy 3 greater than IE2. I2 greater than I1 greater than I1. See here first IP is given 590, second IP is given 1145. Here jump is very less. Jump is less. Jump is less. Jump is less means this is a alkaline earth metal. This is a alkaline earth metal. Alkaline earth metal. That means X is alkali metals because it is a high jump from I1 to I2. That is the reason. The reason is that after losing one electron, it is achieving noble gas configuration. That's why its IP value increases highly. So this X is alkali metals, Y is alkaline earth metal. What is the answer then? X is alkali metal, Y is alkaline earth metal. Option number 2 is the correct one. Next question number 14. Question number 14. If you go to question number 14. Question number 14. What is the question? From the following pair of ions, which one is not isolated? Which one is not isolated? Isolated just now I said same number of electron, same number of same number of electron, same number of electron, but not isolated means which does not have same number of electron. We have to find. Let's say manganese. Manganese 25 atomic number, loss of 2 electron. That means 23. Iron 26 atomic number, loss of 3 electron, plus 3 means loss of 3 electron. 26 minus 3, that is 23. This is isoelectronics. This is isoelectronics. Sodium atomic number 11, plus 1 means loss of 1 electron. That means 10 minus 1, that is 10 electron. Sorry, 11 minus 1, 10. Magnesium atomic number 12, loss of 2 electron. That means 10 electron. This is also isoelectronics. Oxygen 8, gain minus 2 means gain of 2 electron. That means 10 electron. Okay. Fluorine atomic number 9, minus 1 means gain of 1 electron. 9 plus 1 means 10. This is also isolated. 2, 3, 4, these all are isolated. All are isoelectronics. What in the question they are asking which is not isolated? Let's see option number first. Iron atomic number 26, plus 2 means loss of 2 electron. 26 loss of 2 electron, that means 24 electron. Okay. So manganese atomic number 25, loss of 2 electron, plus 2 means loss of 2 electron, that is minus 2, 23 electron. Here 23 electron, here 24 electron. That means these are not isolated. Not isoelectron. Isoelectron means same number of electron, different electron. That's a not isolated. In question they are asking not isolated. That means option 1 is the correct. 14. Option 1 is the correct one. Let's come to question number 15. Identify the incorrect match. Okay, incorrect match you have to find. Mendeleev atomic number is 101. Lawrencium atomic number is 103. Seaborgium atomic number 106. Its atomic number is 110. And that means 110. Then which one is not matching properly? We have to find. On a nil unium. 1 means on, 0 means nil, on a nil. Again 1 means union. This is correctly matched. On nil union. This is correct. This is correctly matched. This is correct. Incorrect you have to find. This is correct. Okay. Then what will be its name? 1 for on, 0 for nil, 3 is there. That's a triumph. Lawrencium, its name will be on a nil triumph. This is also correct. Okay. And Seaborgium. Seaborgium atomic number 106. 1 means on, 0 nil, 6 means hexium. Hexium. This is also given on nil hexane. This is also correct. But they're asking which is incorrect. Dam stadium starting number is given 110. Its name should be on 1. Again 1 on 0 means nil. Yeah. Its name should be on nilium. But the given answer is on unium, on unium, on. That means 1 1 1. But Dub Stadium article number is 110. This is not correctly matching. This is not correctly. DHIP is not correctly matching. Which option? DHIP. This is first option is the correct. We have to find incorrect. That's option number 1 is the correct. Next question number 16. Match the following. I said you just now I said you what neutral oxide, neutral oxide, neutral oxide, some neutral oxide I said you, four neutral oxide, carbon monoxide, CO, NO, N2, laughing gas N2, and H2. These are neutral oxide. Then what is given? Carbon monoxide. Carbon monoxide is neutral. Neutral where? 2. That means A is equal to 2. You can see the option. In option, A is equal to IP, A is equal to I, A is equal to double I, A is equal to third I. Only third option where A is 2 given. That means option number 3 is the correct one. A is 2 given. But you can check also. Barium oxide, this is a metal oxide. Metal oxide in basic in nature. That means B is equal to I. B is equal to I. Next, Al2O3. Amphoteric oxide. Some amphoteric oxide I said you. Amphoteric oxide. Some metal oxides are amphoteric in nature. What are these metals? Aluminum, beryllium, Sn, Pb, and zinc. These metal oxides are amphoteric. What is it given? Al2O3. That means Al2O3. Al2O3 is amphoteric in nature. Al2O3 that means C is equal to I. Cl2O7 this is a non-metal oxide. This is highly acidic. You can see H double I, H double I, B is I, yes, C is fourth one, D is third one. So option number 3 is the correct. Next question number 17. Match the element in the column 1 with the column 2. Okay, column 1, column 2. Copper. Copper is a transition metal. Copper is a article number 29. It is a transition metal. Fluorine is a non-metal. Fluorine is a non-metal. Silicon is a metalloid. Cerium. Cerium is a lanthanoid. Cerium is lanthanoid. Okay. So what is the correct answer? Copper. Copper. That means Ag2. 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 Ag Ag first. First. Option number 3 is wrong. Option number 4 is wrong. Ag2. Either answer should be option 1 or option 2. Next come to B. B is fluorine non-metal. So B is I. B is I. Here given B is IB. Here given B is I. So option number 2 is the correct one. C is IB. C is IB is correct. D is third I. It's also option number 2 is the correct one. Next question for 18. Which of the following oxide is amphoteric in nature? Amphoteric in nature. Just now I said few metal oxides are amphoteric. What are these? Beryllium oxide. Some metal oxides are amphoteric in nature. What are these? Beryllium oxide, aluminum oxide, Al2O3, SNO2, SNO2, and ZNO, PPU. These are the few metal oxides which are amphoteric in nature. Amphoteric. Then what is our correct answer? Which of the following is amphoteric? Amphoteric means SiO2 is acidic, slightly acidic. This is acidic. Also, what is the answer? SNO2. First option is the correct. Next question number 19. For the second period element, the correct increasing order of their ionization enthalpy. Fast ionization enthalpy. Fast ionization enthalpy. You have to find. Second period element. What are second period element? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are second period element. We know leptoride. Leptoride effective nuclear charge increases. Effective nuclear charge increases. That's a IP value also increases. So answer should be like this. Lithium less than beryllium, less than boron, less than carbon, less than nitrogen, less than oxygen, less than fluorine, less than neon. Answer should be like this. What do we know? Beryllium is stable electronic configuration. Beryllium configuration is 1s2, 2s2. Exactly fulfilled configuration. S has 1 orbital, 2 electron. Exactly fulfilled. Stable configuration. Stable configuration. Stable configuration means either exactly half filled or exactly full filled. Beryllium, again, nitrogen has a stable electronic configuration, exactly half filled. Exactly half filled. Its configuration is outer electronic configuration 2s2 2p3. P is a 3 orbital. Its configuration 1s to 2s to 2p3, but outer configuration is 2s to 2p3. 3 orbital, 3 electron. 1, 2, 3. Exactly half filled. This is exactly half filled. Half filled configuration. Half filled, exactly half filled means stable configuration. This is also stable configuration. Beryllium, full filled configuration, fulfilled stable configuration. Nitrogen, exactly half filled stable configuration. If they have stable electronic configuration, they will not lose electron easily. That's why their IP value will be more compared to their next member. Their IP value will be more compared to their next member. That means beryllium IP will be more than that of boron. Nitrogen IP will be more than that of carbon. So what should be the order now? What is the exact order? Beryllium will come here, boron will go there, nitrogen will come here, oxygen will come. Due to their stable electronic configuration, their IP value will increase. Uh, increase. That means their IP value will be more than its corresponding next member. Okay. Then what is the correct answer? Lithium less than boron will come here. Boron less than beryllium less than carbon less than nitrogen will go there. Oxygen will come here. Oxygen less than nitrogen less than fluorine less than neon. What is the correct answer you find? Neon, fluorine, nitrogen, neon, fluorine, nitrogen, oxygen, carbon, boron, carbon next to carbon. Here beryllium should come. Okay. That means option number 3 was lithium less than boron, less than beryllium, less than carbon, less than oxygen, less than nitrogen, next than fluorine. This is the correct one. Option number 3 is the correct one. 19. Option number 3 is the correct one. Next question number 20. Which of the following oxide is acidic in nature? Acidic in nature. Acid. Which of the most acidic? Most acidic. These all are metal oxide. All are alkaline earth metal. What are these alkaline earth metal? Beryllium, magnesium, calcium, strontium, barium. These are alkaline earth metal. These are metal means their oxide is basic in nature. Oxides are basic in nature. What is their oxide? Bu. What are the given? Bu, MgO, BaO, sorry, here calcium will come. Next is CaO, BaO. These all are metal oxides, so these all are basic in nature. All are basic in nature. But we know top to bottom, metallic character increases. Metallic character increases. As their metallic character increases, that means basic nature of oxide also increases. Basic nature of oxides also increases. We know metal oxides are basic. As metallic character increases from top to bottom, that's mean basic nature of oxides is increases. But in beryllium oxide, magnesium oxide, calcium oxide, barium oxide, basic nature increases means barium oxide will have highly basic. It will be highly basic. It will be highly basic in nature. It will be highly basic. Highly basic means what? Least acidic. Highly basic means least acidic. Least acidic. Okay. If barium oxide is highly basic, so beryllium oxide will be least basic. It will be basic in nature, but least basic. Least basic means most acidic. Least basic means most acidic. In question they are asking which is most acidic. Most acidic means beryllium oxide is the answer. Beryllium oxide, option number two. Option number 2 is the correct answer. What you understood from this question, we know top to bottom metallic character increases. So beryllium to barium, metallic character increases. Metal oxides are basic in nature. As metallic character increases, so basic nature of oxide also increases. So barium oxide has a highly barium oxide will be highly basic. It is highly basic. So beryllium oxide will be Least basic means most acidic. Question they are asking most acidic. So beryllium oxide is the correct answer. Question number 21. The element atomic number 114. Atomic number is given 114. Okay. Has been discovered recently. It will belong to which of the following? Which of the following family or group? The electronic configuration. Z atomic number is given 114. Their electronic configuration also given. So which one is correct of the five? It's very easy question. See here, atomic number is given 114. Atomic number 114. But we know radon atomic number 86. 86. 5 14. That means 14. That means 100. Again 10. 110. Here 2 plus 5. 2 plus 5. That means 86 plus 14, 100, 110, 112, 105. And 12 plus 5, that is 117. But atomic number is given 114. This is not our correct answer. Okay, next come to carbon family. Red and atomic number 86, yes, okay. Next 5 14, 5 14, 14 electron. Next 60, 10, 10 electron. Next 7 is 2, 7p2. 2 plus 2. That means 86 plus 14, 100, 110 plus 2 plus 4. That means 114. Atomic number 114 is given. We are getting 114. So this is the correct answer. This is the correct answer. Let's check for option number 3 and option number 4. Radon 86 plus 14, 100, 110, 112 plus 4, 116. Okay. So here radon 86, 1400, 110, 112 plus 6, 118, 118. Here 116, 118. Here we are getting 114. Here we are getting 117. In question there in question Z value is given 114. That means option number 2 is the correct answer. Carbon family, and this is the configuration. Next question number 22. In which of the following option the correct arrangement does not agree with the variation of the property indicated? Okay, this is a very nice question. Lithium, sodium, potassium, rubidium increases metallic radius. Yes, this is correct only. These all are alkali metals. Lithium, sodium, potassium, rubidium. We know top to bottom metallic size increases. Top to bottom atomic size increases. Top to bottom atom size increases means this is the increasing order given. So this is the correct one. But we have to find which does not agree. Not. Okay. This is correct one. Next Al3 plus Mg2 plus Na plus F minus. Increasing order of the ionic radius. Ionic radius, just now I said ionic radius. In case of ionic radius, ionic, these are all are isoelectronics. You can check it is 10 electron, 10 electron, 10 electron, 10 isoelectronic. For isoelectronic species, ionic radius inverse proportional to atomic number. Atomic number inverse proportional to atomic number. We know fluorine atomic number is 9, sodium 11, magnesium 12, aluminum 13. As the atomic number increases, ionic size also decreases. Ionic size decreases. Inverse proportional means what? Ionic radius decreases. The atomic number increases means ionic radius decreases. So this is correct. Correct given. This is also correct given. Next, boron, carbon, nitrogen, oxygen increasing order of fast type. Iodine, bromine, chlorine, fluorine increasing order of electron gain enthalpy. Let's see option number 3. Boron, carbon, nitrogen, oxygen. These all are one period element. Boron, carbon, nitrogen, oxygen. Left to right, IP increases. This should be the order. But nitrogen increasing order of fast type. Increasing order of fast type. But nitrogen configuration is but nitrogen configuration has a stable configuration. Increasing order of their fast type. Boron, carbon, nitrogen, oxygen. Nitrogen is stable electronic configuration. What is the stable electronic configuration? 2s2, 2p3. Increasing fast ionization enthalpy. Boron, carbon, nitrogen, oxygen. Okay, 2s2, 2p3, oxygen 2s2, 2p4. As it is stable electronic configuration, its IP value will be fast ionization enthalpy value will be more. So what is the answer? Correct answer will be boron less than carbon less than oxygen less than nitrogen. That means which does not agree. It is not agreeing. Yes, this should be the correct one. What is given? Wrong is given. Nitrogen is given less than oxygen. So this is not agreeing. This is not agreeing. Okay, but this is also correct option. This is also wrong given. Okay, increasing electron gain enthalpy. Fluorine, chlorine, bromine, iodine. These all are one group element only. When top to bottom IP, sorry, what is given? Electron gain enthalpy decreases. So answer should be fluorine greater than chlorine, greater than bromine, greater than iodine. Answer should be like this, but fluorine has less size. Fluorine atomic size is very less. Fluorine as electron atomic size is very less. Electron repulsion will dominate. So fluorine electronegativity will be comparatively less than chlorine. So correct answer is fluorine greater than bromine, greater than iodine. What is the reason? Due to small size of fluorine, repulsion will dominate. This is also what is given iodine less than bromine, less than chlorine, less than fluorine. This is also wrong given. This is also wrong given. This is the third option is also wrong given. So answer is of both 3 and 4. Answer is 3 and 4. What is the reason? I'll tell you. Once again, I'll tell you. Boron, carbon, nitrogen, oxygen, these all are one period element only. So answer should be like this. But as nitrogen is stable electronic configuration, its IP will be more than that of oxygen. This is the correct answer. If this is the correct answer, that means this is the order given. This is the wrong one. We have to find the wrong one. Not agree. That means this is also not agreeing. Option number 4, fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. These all are halogen. Top to bottom, electronegativity decreases. This should be the order, but due to small size of fluorine, its electronegativity value will be less than that of chlorine. Not electronegativity, electron gain enthalpy. Its electron gain enthalpy value will be less than that of chlorine. So chlorine will come here, fluorine will come there. So that this is the exact order of electron gain enthalpy. That means electron affinity. This is the exact order of electron affinity. But here given fluorine is greater than fluorine. Fluorine is greater than chlorine, but exactly chlorine is greater than fluorine. That means this is also wrongly given. So option number 3 and 4 is the correct answer. Next question number 23. The electronic configuration of europium, gadolinium, and terbium. Europium atom number 63 given, gadolinium 64, terbium 65. Atom number is given. You have to find electronic configuration. These all are lanthanides. These all are lanthanides. Lanthanides. Okay. Next, first find europium. Europium atom number 63. What will be its configuration? Xenon 54. Xenon 54 for lanthanide. What n minus 2f will come. That means xenon 6s2. First xenon 6x2. After ns n minus 2f will come. That means 4f. 4f will come. 54 to 56. 56. Then how many electron we have to fill? 63. That means 56 7. 7 electron. 4f7. 4f7. That means xenon 6s2 4f7. Xenon 4f7 6s2. This is correct. 4f7 6s2. This is correct. 4f6 is given. 4f6 is given. This is wrong. This is wrong. That means our answer will be either 1 or 2. Next come to what? Gadolinium. Gadolinium atom number is given 64. Its configuration will be xenon 54. Xenon 54, then 6s2. That means 54 to 56 completed. Next 8 electron. But we know F orbital has F subshell has 7 orbital. F subshell has 7 orbital. 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 orbital. For exactly half filled F7, for exactly half filled F7 will be highly stable. F7 will be highly stable. That is the reason gadolinium configuration will be 5d1 4f7 due to exactly half filled s orbital. Exactly f7 means exactly half filled. Half filled. So what is the correct answer? You can see here 4f7, here 4f8, 6s2. This is the wrong one. 4f7 due to exactly half filled. This is the correct answer. Similarly, you can check the terbium. Okay. Next question number 24. Among the following, the correct order of acidity. Correct order of acidity. You know, number of oxygen increases means number of oxygen increases means acidic nature also increases. Acidic nature of oxide also increase. Acidic nature of oxide increases. As the number of oxygen increases, acidic nature of oxide increases. That's why what will the correct answer here? 4, 2, 0, 1, 3. What will the correct answer? HClO, 1 oxygen, then HClO2, then HClO3, then less than HClO4. Here see 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen. As a number of oxygen increases, acidic nature of oxide increases. That's why HClO4 will have highly acidic. It will be highly acidic. HClO will have least acidic. Acidic. Number of oxygen increases, acidic nature of oxide increases. More oxygen means more acidic. So option number 3 will be the correct one. HClO less than HClO2, less than HClO3, less than HClO. Next question number 25. Gadolinium belongs to 4F series. Atom number 64. Correct electronic configuration. Just now we discussed. Gadolinium configuration. This is the configuration. Xenon 5, Xenon 54, 6s2, 5d1, 4f7. Then what is the correct answer? Gadolinium atom number 64. It's a configuration in Xenon 6s2, 5d1, 4f7. And what is the correct answer? 4f8, 4f9, 4f6, 4f7. One option is given. Option number 3 is the correct one. Question number 25. Next question number 26. For the formation of oxide ion O2 minus from the oxygen atom requires fast and exothermy, then an endothermy is given below. Oxygen will gain one electron from O negative ion. Its delta formation is given exothermy. Negative value is given means exit. That means energy is released. Again after that O negative ion, again it will gain one electron to form O2 negative, that is oxide ion. Its delta S formation is given positive. That means this is endothermy. This positive value means endothermy. First one is given negative. Negative means this is exothermy. This is exothermy. First process is exothermy. Second process is endothermy. What is the reason they are asking? The process of O2 formation O2 minus and gas phase unfavorable. Even that of O2 minus is isolated with the neon due to the fact. Why? What is the reason? This is positive value. We see here. You can see when it will gain one electron, it will form O negative ion. Okay, electron affinity. This is called electron affinity or electron gain enthalpy. Electron affinity or electron gain enthalpy. First is always exothermic. Okay, energy is released. But after the formation of one negative ion, it is a negative ion, negative charge. Electron is also negative. Negative. They will repel each other. To overcome this repulsion, we have to supply some energy. That's why electron affinity 2 will be endothermic. Electron affinity 1 is exothermic. Exothermic. That means energy released. But after formation of one negative ion, again if one electron will come to its outer shell, this negative charge and this electron also negative, this is also negative, so they will repel each other. When they will repel each other, this process will be difficult. That's why we have to supply some energy. That's why E2 will be endothermic. Then what is the correct answer? First option, electron repulsion outweighed the stability gained by the achieving normal. This is the correct answer. Electron repulsion. After the formation of one negative ion, when one more extra electron is coming, they will repel each other. This is the correct answer. Next question number 27. Which of the following order of ionic radius is correctly represented? Al3 plus, Mg2 plus, N3 minus. These all are isoelectronics. Aluminum 13 plus 3 means loss of 3 electron, 10 electron. Here also 10 electron. Here also 10 electron. Isoelectronic means radius inversely proportional to atomic number. Atomic number inversely proportional to atomic number. That means aluminum radius should be least, then magnesium, then nitrogen. So its correct order should be nitrogen greater than magnesium greater than aluminum 3 plus, magnesium 2 plus, and 3 minus, and 3 minus. This is the correct order. That means this is given wrong. H minus H plus H. We know size of size of anion always greater than that of neutral atom, and neutral atom greater than cation. Size of anion is greater than neutral atom greater than cation. But here see anion, then cation, then hydrogen. So this is wrong answer. Or correct answer should be H minus greater than H greater than H plus. Here sodium plus F minus O2 minus. Similar concept. First and third. All are isoelectronics. Isoelectron means reduce inverse proportional to atomic number. Sodium atomic number 11. So the radius should be least. Answer should be like this. Sodium less than chlorine less than oxygen. So this is also wrong. Option number 4, O2 minus F minus Na plus 10 electron, 10 electron. Here also 10 electron. That means these are isoelectronics. Isoelectron means radius inverse proportional to atomic number. Atomic number sodium 11, fluorine 9, oxygen 8. So inverse proportional to atomic radius means oxygen oxide ion will have greater radius than F minus and then Na plus. This is correct. Option number 4 is the correct one. Next question number 28. Beryllium 2 plus is isoelectronic with which of the following? This is a very easy question. Beryllium, atomic number 4. Its configuration 1s2, 2s2. Okay. Beryllium 2 plus. Beryllium 2 plus means loss of 2 electron. Loss of 2 electron means this 2 electron will go. Its configuration is 1s2. That means 2 electron. It has 2 electron. Isoelectron means same number of electron. That means among these following species which has 2 electron. Magnesium has 12 electron plus 2 means loss of 2 electron. 12 minus 2 is equal to 10 electron. It is not isoelectronic with beryllium. Okay. Hydrogen has 1 electron plus 1 means loss of 1 electron. That means 0 electron. This is also not isoelectronic. Lithium atomic number 3. It is 3 electron plus 1 means loss of 1 electron. That means 2 electron. So it is isoelectronic with beryllium 2 plus. Beryllium 2 plus has 2 electron. Lithium plus has also 2 electron. That's why these are isoelectronics. Isoelectronics. That means option number 3 is the correct one. Next question number 29. Identify the wrong statement among the following. Amongst the isoelectronic species, smaller the positive charge on the cation, smaller is the ionic radius. No, this is wrong. Isoelectronic species just now we discussed. Here we discussed. Okay, I'll take one example and I'll explain them. Isoelectronic, let's say Al3 plus 10 electron, Mg2 plus 10 electron, Mg2 plus 10 electron, Na plus also 10 electron, 10 electron, 10 electron, 10 electron. That means these are isoelectronic species. For isoelectronic species, atomic number 13, 12, atomic number 11. Atomic number more means radius will be less. So answer is this. This is the ionic radius order. Ionic radius. Then what are you observing from this? More positive charge means less is the radius. More positive charge, more positive charge, more positive charge in isoelectronic species. Isoelectronic species. More positive charge in isoelectronic species implies less is the radius. Less is the radius. My radius. But here you can see smaller positive charge, smaller is the radius. No, more positive charge, smaller is the radius. This is the wrong statement. Okay, that means okay. Identify the wrong. That means our answer will be first option. Our answer will be first. We have to find the wrong statement. Okay. Next. Okay. Thank you all for watching this video. If you are getting any information from this video, if it is helping for your preparation, then please do like, share, and subscribe my YouTube channel. If you want this PDF of this explanation, you can join my Telegram channel. I will give the link of this Telegram channel in description. Thank you.